Alright, so you have a function f of x equals the absolute value of x plus 2x. And we know that if you have an even function or an odd function, then you don't have to calculate the half of it because they become 0. So it's nice to have an even function or odd function. So let's try to investigate what you have. First, 2x. I know that that's an odd function because it's x to the first power. For polynomials, x to 1 or 3 or all these odd powers, they're odd functions, right? And any multiple of an odd function is an odd function. Any constant multiple of an odd function is an odd function. So we know that that's an odd function. But what about the absolute value of x? Absolute value of x has this following graph, like that, right? And that's definitely symmetric with respect to the y-axis, so we know that this is what? Even or odd. So this is even, whereas this one was odd. Okay, so if you have an even function and an odd function added together, that's no symmetry. Yeah, it doesn't. If you add an even function and an odd function together, it's neither even nor odd. So unfortunately, that means you have to calculate both an and bn because neither of them will be 0. Okay, so that's what you have. Okay. However, we'll still try to use the property of even and odd to simplify the calculation, and probably you'll see how you can still use that property to simplify. Okay. All right, solution. Let's first write down the formula for the Fourier series. First, the Fourier series is a0 over 2 plus sigma n from 1 through infinity an cosine n pi over lx plus bn sine n pi over lx, where an's are calculated by 1 over L from negative L to L f of x cosine n pi over Lx dx, and bn's are calculated by 1 over L, negative L to L, f of x cosine sine n pi over L x dx. Okay, so that's the formula, and although I only wrote 2 formulas, actually this one formula is actually 2. You have to calculate a0 and an separately. Okay, so that's a big warning here. Even though if you see just one formula, this is actually 2. So we actually have three integrals to calculate. Okay, so let's do them one by one. Okay, so start with the easiest one, a0. What's a0? a0 is the integral. Oh, before we do that, we should figure out what L value is. What's the L value?
3.
L is 3 because it's from negative L to L, and we have negative 3 to 3. So the value of L is 3. So 1 over 3 integral from negative 3 to 3 of absolute value of x plus 2x dx. Okay. So we have, and another thing I forgot to mention is that this is a0, so n is 0. That means this n is 0. What's cosine of 0?
1.
That's 1. That's why I don't have any cosine. Okay. So the reason I'm saying that this is actually 2 formulas is because for n equals to 0, you don't have the cosine. Therefore, when you do calculations like this, there's no need for using integration by parts. That's why the calculation turns out to be completely different for the case when n is 0 and when n is non-zero. Okay, so this is what you have to integrate, and then you see that you can split this integral into 2, right? You can split this into an integral of absolute value of x and an integral of 2x. And this is when you get to use the property of even and odd, because this is even, that's odd. Which one's 0? No, the odd one. If you integrate an odd function over a symmetric domain, you get 0. Okay. This is the one that's 0. Then what about this? It's an even function. What can you do with an even function? You can take half the interval and double the integral, right? So you say it's 2/3 of 0 to 3 of absolute value of x dx. But if x is only varying from 0 to 3, do you need the absolute value? No. Absolute value of x is just equal to x if x is already positive, right? Because absolute values don't do anything if your function is already positive. So you just have x. And that's easy to calculate. This is 2/3 of integral of x is 1/2 x squared. And you're plugging in 3 and 0. 2 cancels. When you plug in 3, that's 9. 9 divided by 3 is 3. So that's what you get. Okay? So the integral value is 3. So that's the value of a0. We found a0. All right, 2 more to go. We have to find an and bn. But hopefully this calculation shows you how to make use of the property of even and oddness of each individual functions. Okay? Because we'll need that too for the next 2 calculations. Okay? So we have an as 2 over, why did I say 2? That's later. Okay. So an is 1 over 3 from -3 to 3, absolute value of x plus 2x times cosine of n pi over 3x dx. Again, you want to split this into 2. See, I can distribute this so that you have 2 terms. And the first term is this one, whereas the second term is 2x cosine n pi over 3x dx. Okay. Now, which one is 0?
2x.
2x. This one is 0. Because this is an odd function. This is an even function. Here's a symmetric domain. Okay. Odd times even is? Odd function, right? So you have an odd function integrated over a symmetric domain, you get 0. So that goes away. Now what about this? This is even, that's even. Even times even is?
Even.
Even, therefore what do you do?
Take half integral.
Double the integral with half the integral. And again, we use the trick that the absolute value of x is same as x if x is only taking the values of positive. Okay? Now, this is much easier to calculate than what we originally had. Okay? If you were to just integrate it, if you had to integrate this as it is, then you will have to break up this interval into 2, and then you'll have to do 2 integrals with tabular integration. It'll be a mess, okay? But just because we are using this property of even and odd, the calculation becomes much easier. Much easier, okay? All right. So now we have to do plus minus d integral x 1, 0, and cosine n pi over 3x integrates to 3 over n pi sine n pi over 3x. See, the reciprocal of this number always pops up front, okay? You have to flip this and put it here, okay? And then when you integrate sine, it's negative cosine, and another reciprocal of this pops in front, so that 3 over n pi is multiplied to this again, which gives you 9 over n squared pi squared with cosine n pi over 3x. Okay. The signs alternate starting from positive, and then you do this and this, okay, and then the last one like that. The last line doesn't produce anything because you're multiplying by 0, so you only have to calculate these 2. Let's see, this will give you, well, let's write down the result here. So here, if I multiply positive x times this, you get 3 over n pi x, let me take a different color. It's not working. So let me write it again. It's equal to 3 over n pi x sine. Oh, sorry. I shouldn't forget 2/3, right? 2/3 of 3 over n pi x sine n pi over 3x. And then negative times negative is positive, so it's plus 9 over n squared pi squared, then sine n pi over 3, no, cosine n pi over 3x. That's right, right? Minus times minus positive, 9 over n squared. Okay. And then to this, I have to plug in the endpoints, which are 3 and 0. Okay. First, if I plug in 3 to here, what do I get?
0.
0, because if I plug in 3 here, 3 and 3 cancels, leaving you with sine n pi. Okay? And please, let's not forget these two important things, which is that sine n pi is 0, and cosine n pi is negative 1 to the nth power. Okay, very important. Okay? So using that, we end up having 0 when you plug in 3, whereas if you plug in 3 here, you get cosine n pi, and using that, it's negative 1 to the nth power. Okay, so it's 2/3 of 9 over n squared pi squared of negative 1 to the nth power. That's what you get when you plug in 3. Okay. Now when you plug in 0, 0 goes in here, and therefore 0 times anything is 0, so that goes away. When you plug in 0 here, what do you get? What's cosine 0? 1. Therefore, this becomes 1, and you get 9 over n squared pi squared. Okay? And the way you do definite integral is you plug this in, and you subtract the 2. So we have to subtract the 2. This is what we get. And then if I multiply 2/3 to each one of these, 9 over 3 is 3, right? 9 divided by 3 is 3, and then you have to multiply by 2, so it's going to be 6 over n squared pi squared for both of them. And since I get that for both of them, I can factor this out, and I get negative 1 to the nth power minus 1. Okay? So that's your AN. So that's your AN. Still one more. Right? We have to find Bn. So let's do the Bn again. Bn is 1/3 negative 3 to 3 absolute value of x plus 2x sine n pi over 3x dx. Okay. Hopefully by now you know which one to delete. Which one's going to give you a 0? Absolute value of x. This one times this will produce an odd function, because sine is an odd function. This is an even function. Even times odd is going to produce an odd function. Therefore, this is not needed. You won't need it. Okay? This is going to produce 0 when you expand and integrate. Okay? Hopefully, when I skip this step, you'll understand. Okay? So, and then this is odd. Odd times odd gives you even. So you can rewrite this as 2/3 integration from 0 to 3 of 2x sine n pi over 3x dx. All right? And that one, again, requires tabular integration. So let's try it. Plus minus d integral 2x differentiates to 2, 2 differentiates to 0. And then sine n pi over 3x. Integrating gives you 3 over n pi with minus cosine n pi over 3x. And then integrating this again gives you negative 9 over n squared pi squared sine n pi over 3x. And then it's plus minus plus. Again, do this and that. Let's see, what's the result then? The result is, let's write it here. 2/3 is still there, but then it's 2x times 3, negative 3, so it's negative 6x over n pi cosine n pi over 3x. Okay. And then negative times negative is positive. 2 times 9 is 18, so it's plus 18 over n squared pi squared sine n pi over 3x, and to this I have to plug in 3 and 0. Okay? Now let's see what we get. When you plug in 3, you get cosine n pi. What do you write? You plug in 3 cancels, you get cosine n pi, you write? Negative 1 to the nth power. And 3 going here, it's negative 6. 3 times 6 is 18. So it's negative 18 over n pi, negative 1 to the nth power. Okay? And then when you plug in 3 here, you get cosine n, sine n pi. What do you get? 0. Sine n pi is 0. Okay. When you plug in 0, because you're plugging in 0 here, 0 times anything is 0, so that's gone. When you plug in 0 here, that's sine 0, which is 0. So what do you get if you plug in 0?
0.
Nothing. Okay, 0. And therefore, when you subtract 0, it's this, so that's your Bn. Okay?
Do I have to times by 2/3?
Oh, did I forget? Oh, keep forgetting that, yeah. Don't make that mistake, please. Okay? So 3 and 18 cancels, and you get 6. 6 times 2 is 12, so negative 12 over n pi, negative 1 to the nth power. And then, is that the answer? Did we get all the answers?
Plug them all back in.
You have to plug them all back into our original form, or else you didn't obtain the Fourier series yet. We only got the coefficients. You need to find the final series. So let's write down the answer right here. Let's see. So the answer is f of x is what? A0 is? We got 3, so it's 3 over 2. Sigma n from 1 through infinity. What do we get for an? It's 6 over n squared pi squared of negative 1 to the nth power minus 1 cosine n pi over 3x. Okay. Now I need more room, so let me erase this one also. Now for sine, what did we get? We got negative 12 over n pi, negative 1 to the nth power. That's the Bn, so I attach it to sine n pi over 3x. Okay. And this, if you draw the graph of the right side and compare it to this function, you'll see that they are exactly the same. So that's the answer.